We begin our chat on t-tests with wheat and barley, and that's because the t-test, as we know it, was brought to us by William Seeley Gossett, who is not only a statistician, he was a student of Pearson's, the Pearson's R. Pearson guy. He was also a chemist, and interestingly enough, he was also a brewer who worked for Guinness. And in his search to figure out the best yield of crops, he developed the tea distribution, which fits small samples better than the normal distribution. And that's where tea tests come from. What I want you to remember for now is that T is for 2. Specifically, we're looking at the differences in means between 2 groups or 2 samples. So let's say that I draw one sample here and map out its mean right down the middle. I'm going to call it 1. And the second one I draw here, and I'm going to creatively call this one 2. I'm looking at the differences right here. This area is what I'm interested with a t-test. What is the difference in means between these 2 groups? And t-tests come in 3 flavors. 1 sample t-test, 2 sample t-tests, and 2 sample paired t-tests. Now, 1 sample t-test, I can hear you already thinking, wait a minute, didn't you just tell me that T is for 2? What's going on here? Well, T is for 2. It's just that sometimes we want to compare what we have against a known value. Okay? So we call this one 1 sample t-test because we already have data on one variable and we're bringing it to compare our data against it. In nursing, this is somewhat less common, but you can think of it in terms of maybe comparing a particular sample to the population, right? The mean of a sample to a known mean of a population, or the mean of your particular group to a, let's say, like a national standard or some reference value. Okay, that's where you would use it. So let's say that you were interested in looking at family nurse practitioner passing rates in your class, in your cohort against, you want to compare it to what the national mean for the F&P boards were. You would use a 1 sample t-test, okay? Or let's say that you wanted to look at CAUTIs in your hospital in all the various units and compare them to say what the average CAUTIs are in the state or the nation. Again, you would use the 1 sample t-test. The 2 sample t-test, also called an independent t-test. I don't like to use that independent because sometimes it confuses students with independent versus dependent variables. I'd rather not call it that. But the thing for you to remember is that here, again, we're still looking at 2 groups, right? But the groups now are not related. These are unrelated groups. So they're different members in each group. Some examples can include if you're looking at differences between males and females, right? Or say between freshmen and seniors. Or you're looking at the differences between those that received a certain treatment or drug and those that received a placebo. Here you will use a 2 sample t-test. The thing to remember again is you're looking at separate groups, right? And the opposite of that would be when the 2 samples or the 2 groups are related. We use a paired t-test, also called a dependent t-test, which I don't like to use because you know how I feel. And here we're looking at 2 groups, but they're related. All right. Often it's the same group. The scores, therefore, are paired. So examples would be, before and after, treatment, or say at the start and then at some other particular time. Those are very, very useful and broadly used in nursing, the 2 sample paired t-test. Now, how do we select the appropriate t-test? How do we figure out from these three different flavors which one fits our data better? Which one is the one that we really want to use in our project? You just have to ask two questions. The first one is, am I starting out with a known value? Do I have a comparator? Do I have a standard? Do I have already one value that I know? If the answer is yes, then it's simple. You use a one sample t-test. If the answer is no, then you come up with your second question, which is, okay, from the two groups that I have, are they related? Are we talking about separate groups? Are we talking about the same group that I'm measuring this particular change or effect in? If the answer is yes, the groups are related, then you use a pair test. If not, then you don't. Easy peasy. Okay, now how do we actually do this on Excel? Let's go through that. We're going to start with a one sample t-test. And before we start, I want to make sure that you have already installed the Analysis Toolpak add-in in Excel. If you have not, I have a video you can watch. But if you have already, then once you hit the Data tab here, you will see it pop up right there, Data Analysis, and that's what we're going to use. Another step too before we get going with analysis is, before we get started, there are certain things that we want to do with our data to make sure that everything's good to go. And I have another separate video in which, for example, we go over assumptions, right? Every test has assumptions that need to be met. But right here, we're assuming that we've already done that. We run some descriptives, we're familiar with the data, and now we're getting down to analysis. Okay, let's get familiarized with our data set here. We have two variables, two groups. One is the IQ of 20 nurses, 20 graduating nurses, and we want to compare that to a known value, right? That's why this is a one sample t-test. The known value is the IQ for all graduates, say national mean, okay, the national average. We want to compare those two. We go to data analysis, and in Excel we have three different types of t-tests that we can use. We have an option for the paired t-test, and then we have an option for two sample with equal variances and two sample with unequal variances. I'll go over that in just a second. As you might have noticed, there is no option for a one sample t-test. So what we do is we actually add another score, the same number, for our comparator group, our standard, okay? We just add another one. We go under data analysis, and the specific test that we're going to choose is the two sample with unequal variances. When we select this by hitting OK, it brings up our next window, which is asking us for our first variable. Make sure that you select your variables by clearing whatever's there first, and we go over to our first variable and we select that column, just the numbers. We do the same for the second, and we're going to include that extra one that we added. Okay, notice I got labels, so I want to make sure that that box is clicked right there for my labels. Also check your alpha, make sure that it's what you have it set, which you've gone for 0.05. And this last one here is where I want the results to show, and I'm picking there. I click OK, and that's exactly where they come up. Now our results, the first thing that we're going to look at is at the means. And if you look up here, we got our mean for nurses was 113.98, which is basically 114. So we can already tell that there really wasn't much difference. Now, was it statistically significant or not? That's the next question. And in order to find that, we're going to look at our p-value, and Excel gives us two choices. It gives us one tail or two tail. In this case, we have no idea which way the IQ is going to go, whether it's going to be higher or lower. So we're going to pick the two tail option, and as we see, it is not less than 0.05, meaning that there are no statistically significant differences between the means in the IQ between our nursing group and college graduates at large. Great. 1 out of 3. Let's go for the second one. And it is a 2-sample t-test. Okay, so here I'm looking at 2 different samples. And in my particular example, I'm looking at the Braden scale scores across 2 different nursing homes. All right, nursing home 1 and nursing home 2. For those of you not familiar with the Braden scale, it is a score on the risk for the development of pressure sores, and the lower the score, the higher the risk. Now, in our particular example, we're looking at 2 different nursing homes, meaning that these are not related groups. They are not paired, right? Also called independent. These are separate groups. So, if you remember back at our options for 2-sample paired tests, Excel gives us 2 choices. We can run the t-test assuming equal variances, or we can run the t-test assuming unequal variances. Now, each of these tests are different. They have different assumptions. They use a whole different set of numbers and calculations. So we have to know whether or not our variances are equal. And in order to do that, we have to run another test. And thankfully, Excel allows us to do that right here through an F-test. This is nothing to stress much about. This is just an additional test that we are doing to test the variances, whether or not they're equal. The test has its own null hypothesis, as all tests do, of course. And the null for the F-test is that variances are equal. All right, so if the P for the F-test is not significant, say it's greater than 0.05, we cannot reject the null, and the variances are equal. If, however, the P is less than 0.05, we reject the null, and the variances are not equal. Got it? Okay, so how do we go about doing this right here in Excel? Let me get rid of this. And we go back to our data analysis. And in our tests, we have an option for it right here, F-test 2-sample for variances. We simply click it, and now we're familiar with the same format, like just like the t-test. And it's asking us for our first group. I'm gonna select my first nursing home as the first group. Note that there's differences in scores right here, right? In the number, the n is different in both groups. We can do that, all right, because they're not paired. We select it again. I double check that my labels are there. 0.05 is what I want, and I want to pick a spot to put it. I'm going to leave it there. I click OK, and here are my results. Now, looking at the means, it looks like for nursing home 1, it's 15.5, the mean Braden score, and for the second nursing home is 17.2. I check what my p-value is, and notice it's just one tail, so I don't have to think about it much. But it is significant. It is less than 0.05. Now remember what the null is. The null is that the variances are equal. And we are rejecting the null because we have a significant value here. Therefore, the variances are unequal. So now we know what to choose when we run our t-test, unequal variances. And that's exactly what we're doing next. We are going to select a t-test 2-sample for unequal variances. We click OK, and we're back to selecting our groups. And make sure that you select it every time. Don't trust those whatever values are on there, okay? Because it may remember wrong. So I'm picking my 2 groups. Again, I check that my labels value is on there, 0.05, and I'm going to select where I want it. I want it here in this spot. I click OK, and here are my results. I've checked my means previously, but looking at them, they are both actually under the mild risk category. So both nursing homes are under mild risk for a pressure ulcer. Uh, I have no reason to think that it's the differences should be one direction, so I'm going to pick a two-tailed test. And when I look at my P for two-tailed value, I can see that it is not significant. It is greater than 0.05. So my t-test will show me that there are no statistically significant differences in Braden scale scores between nursing home 1 and nursing home 2. And I would say too that as far as clinical significance or importance, there really isn't any either, because they're both in the same uh, category. All right, 2 out of 3 ain't bad. So let's talk about our third and last t-test. That is our two-sample paired t-test. Uh, Now what I've done here is I have a group of nurses that I have given the mini mental state examination, which is a measure of cognitive impairment. Okay, and what I have done is uh, for this one group of nurses, at the start of 4 12-hour shifts, I have given them the MMSE, and then at the very end on their fourth and last 12-hour shift, I have given them the same exam again. Okay, and I'm going to see what their score is and see if they're showing any differences in categories in terms of cognition at the start of the working streak versus at the end of the 4 12-hour shifts. Another thing to remember is that these are the same folks, right? It's a before after type design, so they are clearly related, and these are paired scores. Now in Excel, we go back to our data analysis tab, and this time we're going to select t-test paired two sample test. That is our choice. And everything else is pretty similar to what we've already done. We select our first group. These are the nurses, whoop, hang on. Don't have it quite right. These are the nurses at the beginning of the 412s. This is their score. And I'm going to compare them uh, with their own scores at the end of the 4 12-hour shifts. I'm going to click the label, and that's what I want is 0.05. I don't want it in a new sheet, I want it in this same sheet. So I'm going to select where I want the results, click OK, and boom. What do we got? Okay, now here are results. And now I haven't discussed how to write up our t-test results, and I am going to show you how to do that with this last example. So I'm going to look at the variance as well here, because this is going to come in handy for us when we report. Okay, so let me highlight what the mean is. And for at the start, it looks like it was 28.2. And at the end of the 12-hour shifts, it was 26.7. I've highlighted the variance, and again, this is for reporting purposes, which we will talk about in a second. And lastly, I want to look at what our p-value is. And here I'm looking again at a two-tail test, because I don't have any reason to think that it would go one way or the other. And what I see is that the p is less than 0.05. In other words, there is a statistically significant difference in means in the MMSE in nurses between the start of their 4 12-hour shifts and the end of the 4 12-hour shift. Now, as far as whether or not this is clinically significant, That's a good question because as we can see, the values, the 26 something and 28 something, both are within the normal range or the normal findings. Uh, so one can, make whatever you want about those findings, but in this case, we do have a statistically meaningful uh, result that may or may not be clinically important or meaningful. And I'm going to let you guys decide whether or not that is clinically meaningful. Now, in terms of writing up our statistical findings, and this goes, of course, for every test that we've done in this video, right? Uh, the question is, what do we report? What do we write up? And how do we do it? So we want to report our T. And when reporting the T, you should report degrees of freedoms as well. And as well as the actual value of the T in the test. And this is all right here in our Excel output. And our degrees of freedoms are reported right there under DF. And the T, you want to report the T stat, not the T critical value. Okay? In addition to that, we want to report our P, and importantly, the mean, of course, and the standard deviation. In statistics, we almost always, whenever we report a mean, we give the standard deviation as well. Now, the advantage for reporting the standard deviation over the variance is that the standard deviation is in the same units. So we prefer to report the standard deviation. In order to do that, I don't know why Excel doesn't output it for this particular test, but we can calculate it ourselves fairly easy. And the way we do that is by remembering that the standard deviation is the square root of the variance. So we already have our variances, so let's calculate standard deviation. And Excel has a function for that, a function for the square root. And a function is just a shortcut. It's a formula, right? And in order for us to get the function of the square root, we just type equal and start typing square root, and it pops up right there. I double click on it, and now I got to tell it what cell do I want to get a square root from, and I'm just going to click on my variance, which is what I'm interested in, hit enter, and it automatically calculates my square root. I'm adjusting the decimals here, and there is my standard deviation, the square root of the variance, and it is in the same units that the MMSE is originally measured in. So that's what we prefer. Okay, so now I'm pasting in here what I'm going to report, which is the means for both the pre-12 hours and post-12 hour shift MMSEs, including their standard deviation. We want to report the T, and the T comes with the degrees of freedom as well as the T-stat, which we get right here from our results. Lastly, we want to report our P, and our p-value, according to APA standards, we should always report the exact number, so it should be p equals whatever it is, unless that value is less than 0.01, which that's the case with us. And if that's the case, then you should report p is less than 0.01. And there you have it, 3 types of t-tests using Excel. I want to thank you for watching. Please give me a thumbs up and subscribe. And if you're a DNP student in need of statistical support for your project, visit my website, phdnurseconsult.com, in the description. Thanks.